Deep inside the mountainous forests of central China, a highly specialized biological machine is currently hard at work. It spends up to 16 hours a day performing one task: stripping, crushing, and swallowing massive quantities of bamboo. But if we look at the giant panda's taxonomy, we find a contradiction. The panda belongs to the mammalian order Carnivora. This is a group of mammals that share a common meat-eating ancestor and possess digestive tracts originally built to process animal protein. Yet the giant panda consumes almost zero meat. 99% of its daily caloric intake comes entirely from bamboo, a tough, fibrous grass that is exceptionally low in nutrients. Its short, carnivorous digestive system can only process a fraction of what it eats, forcing it to consume up to 40 pounds of vegetation every single day just to survive. Looking at this structural outline, we can compare the giant panda's proportions to its closest relatives. The panda's massive, rotund body plan contrasts heavily with the more agile, streamlined forms of the American black bear and the red panda. Transitioning from an agile meat-eater to a heavy herbivore required immense evolutionary time. The panda didn't simply change its habits. Over millions of years, its lineage underwent extreme physical modifications across its entire anatomy to bridge this gap. The animal we see today is a re-engineered biological machine, forced to adapt to a specific ecological niche to survive. To consume 40 pounds of bamboo a day, a panda must efficiently grip, twist, and shred smooth, woody stems. This presents a mechanical problem for a bear, because bears do not possess opposable thumbs. The anatomical solution lies in the forepaw. The panda possesses a false thumb, an enlarged radial sesamoid bone typically found in the wrist, extending outward to act as a makeshift sixth digit. It allows the panda to pinch and lock a bamboo stalk firmly against its true fingers. Evolution could not produce a true independent thumb because bears have a plantigrade skeletal structure. Plantigrade means the animal walks with the entire sole of its foot flat on the ground. Because of this, the false thumb is flat enough to safely absorb the massive weight every time it steps. The paw represents an evolutionary compromise. It balances the ancestral requirement to bear heavy loads while walking with the necessity to hold and process tough vegetation. Moving up from the paws, we find the panda's iconic oversized round head. This specific shape generates massive crushing power. Strip back the soft tissue, and the skull architecture reveal the machinery. The panda features widened zygomatic arches, the cheekbones, and a massive sagittal crest, which is the ridge of bone running along the top center of the skull. These structures anchor jaw muscles that are large enough to drive the molars through solid wood. This chart plots the bite force quotient, or BFQ, of the giant panda against other modern carnivores. BFQ is a metric that measures an animal's bite force relative to its overall body mass. Because of its specialized skull, the panda exhibits extreme durophagy, the ability to crush bone or dense wood, giving it one of the highest bite forces relative to its size of any land carnivore. This cranial engineering traces back over 11 million years to small, opportunistic meat-eating ancestors like Cretzoarctos beatrix. As the lineage's diet shifted entirely toward tough plant matter, the skull morphed and thickened to handle the increasing mechanical stress. The panda's rounded face houses a biological engine built to shatter wood. Surrounded by those distinctive black patches, the panda's eyes have often led to the misconception that their vision is entirely useless. Recent behavioral studies using eye-tracking technology show that pandas are severely nearsighted. By human standards, their vision is comparable to 800 degrees of myopia, meaning objects blur out completely just a few meters away. But in a dense, foggy forest, sharp distance vision provides little biological advantage. What they lack in distance, they replace with specific color detection. Pandas possess dichromatic color vision, meaning their eyes have two types of color receptor cells. This allows them to distinguish specific hues, like shades of green and blue, from a gray background. This color filtering helps the panda identify the most nutrient-dense bamboo stalks in its immediate vicinity. The black and white markings, around their eyes and bodies, serve a secondary visual purpose. In the wild, this contrast acts as disruptive camouflage,
breaking up the animal's outline against dappled forest shade and snow. Up close, those dark eye patches likely facilitate individual recognition. The panda's visual system is not a failure of evolution. Instead, distance vision was traded for the specific spectrum of color required to find its only food source. This image shows the rugged terrain of the Minshan mountain range, the core habitat of the wild giant panda. Because their bamboo diet yields such low nutritional value, pandas live on a strict energy budget. They move slowly and avoid steeply sloping terrain to save their strength. This energy conservation dictates how they communicate. Instead of exhausting themselves with vocalizations, pandas rely on passive chemical signaling, leaving scent marks on tree trunks to communicate their age and territory to others. This high level of specialization carries a significant risk. Because its entire anatomy, from its false thumb to its digestive tract, is calibrated exclusively for bamboo, the panda cannot pivot to a new food source. If human development fragments the forest, the panda cannot simply adapt to a new environment. This requirement makes the panda an umbrella species. An umbrella species is an organism whose conservation requires the protection of vast, untouched tracts of its native habitat. To save the panda, we must save the old-growth forests it relies on. By protecting the specialized, vulnerable body of the giant panda, we preserve a massive, interconnected ecosystem. This effort saves countless other species and vital watersheds in the process.